In this video, we're going to punch some holes into a cylinder. And first of all, what we want to do is we want to find out how can we do an object like this. And for objects that have a lot of repetitive detail, sometimes you don't start with what is obvious. So in this case, you might be thinking, let's use a cylinder and punch those holes in there. But that's just not going to work. So what we have to do is we have to break this object down into smaller components. And if you take a look at this one, all it really consists of is a number of square segments with a hole in it. So what we can do is we can model one of these sections and then copy it around horizontally and vertically, and then we can combine all those copies and wrap them around a circle spline using the Spline Wrap deformer in Cinema 4D. So what we're going to do is we're going to start with a circle spline and some geometry that we can wrap around that circle spline. And I'm going to put this circle spline on the floor by changing the plane to XZ, and I don't want it this big, so I'm going to change the radius to maybe 100 centimeters. And now we need some geometry to wrap around this spline, and for this I'm going to use a plane, and I'm going to put the orientation to -Z, and this is pretty much what the final object is going to look like. So we're going to have a number of square segments with holes in them, and we're going to wrap that around a circle spline. For this example, I'm going to change the height to 150, and we don't really need any height segments here, so I'm going to switch these off. And let's say we want 16 holes around that cylinder, and that means we need 16 segments for this plane. So now let's have a look at how we can wrap this object around the circle spline. We need a deformer that is called Spline Wrap. You will find it here. And the Spline Wrap deformer needs to be a child of the object it's supposed to deform. So let's make it a child of the plane object. And we need to tell Spline Wrap which spline to use. So that's going to be the circle. We're going to drop it down here in the spline slot. And Spline Wrap will wrap this geometry around the circle spline, and it will try to make a seamless fit. But you can see that the geometry has changed. It's a bit distorted. The segments are a lot wider than they used to be. So let's have a look at some of the settings in the Spline Wrap deformer. Down here you can see that the mode is set to fit spline. We have two options here, fit spline and keep length. So by default, the Spline Wrap deformer tries to fit the object to the spline, which in this case leads to some distortion. And that is not something we want, because when we have our holes in there, these holes will be distorted too. So let's try the other mode, keep length. And you can see the geometry is no longer distorted, but the plane is not big enough to wrap all the way around the circle spline. So there's a number of things we can do to fix that. We could change the width of the plane, so make it bigger and try to fit it to the spline, or we can change the radius of the circle spline, make it smaller to wrap the geometry around that spline. But I really want to keep that radius of 100 centimeters. So how can we find out how big this plane needs to be? The real question is, how can we find out how long this spline is? Now, of course, we can use a mathematical formula to calculate the length of this spline. But there's an easier way to find out how long this spline is. And what we need to do is, it doesn't work with a parametric spline, so we need to make our circle spline editable. And then we can go to Edit, project info, and you have a structure tab here. And if you click on that, right now it says nothing is selected. I'm not sure why this is happening because we do have the circle spline selected. I'm just going to click on it once again, go to edit project info, and now we can see the spline length. And we can right click and copy that number, and then we can change the size of the plane to just that number. So now if we switch the Spline Wrap object back on, the geometry is no longer distorted, so we're getting a perfect fit here. Let's have a look again at the settings in the Spline Wrap deformer. So right now it's set to fit spline, and the seam is right here. If I switch that to keep length, you can see a slight change here. And if I zoom in very close, you can see that we get a little bit of overlapping geometry. But that's not too bad, because if we use fit spline, the distortion will be so minimal, it's not really going to be noticeable. So that is something we could use. But we can get this perfect, so let's see what else we can do. Right now I think the reason why we get this overlapping geometry is because of the fact that we don't have enough geometry on our cylinder to make it perfectly round, while the circle spline, it has like an infinite number of very small segments that make this spline nice and smooth. So in order to get a perfect fit, we're not going to use a circle spline, but we're going to use an end side. And an end side basically also is a circle spline. The difference to the standard circle spline is that we have easy control over how many sides we want for this end side spline. So let me change the plane to XZ to put it on the floor, and the radius, I'm going to change that to 100 because that's how big we want our final cylinder to be, and we're going to change the sides to 16. So that's exactly how many segments we have on this plane. And now again we have to find out how long this spline is, because the length of this end side is going to be different from the circle we used before. In this case I'm going to make a copy because I want to keep this parametric spline, and I'm going to make this copy editable. And now let's go to edit project info and find out how long that spline is. I'm going to copy the number here, and I'm going to change the size of the plane to that new number. So now if we switch on the Spline Wrap object, and of course we need to tell it which spline to use, this should be a perfect fit. So no matter if we have the mode set to keep length or fit spline, you don't see any change if I switch between these two modes. And that means we have an object that perfectly fits around this spline without any distortion of the geometry. Okay, so that's good. For now I'm going to delete the Spline Wrap again, and I'm also going to delete this one here. So now what we can do is we can make that plane editable, and I'm going to delete all of the segments except for one. And now if we select these two points here, or the entire object, doesn't really matter, we can see the width is 39.018 centimeters, and that is the width that we're going to use to model one of these segments. And we're going to make it the same height, so I'm just going to copy that number here and paste it here, so we get a nice square. And once we've modeled our hole into that piece of geometry here, we can copy it 16 times in the x-axis and a number of times in the y-axis, and then combine all those objects and wrap the resulting object around that end side spline. Next we're going to start modeling the holes into that object. However, I'm not going to use this plane, it's a bit small, so we're going to start with a fresh plane. I'm I'm just switching these objects off here, and I'll go back to frame default, and I'm going to add a new plane to my scene. And we want the orientation to be -z, and we don't need any segments here. And I don't want it to be this big, so let's change the width and the height to maybe 100 centimeters. And in order to get that hole into that polygon here, we're going to use a cylinder. And let's switch that to -z as well. And let's bring the radius down a bit. I'm also going to change the height to maybe 35. Just need to make sure the cylinder penetrates this plane object, because we're going to use a bool object to punch that hole into that geometry. The next question is, how many rotation segments do we need for our cylinder here? We're going to use subdivision surfaces, so we're definitely not going to use 36 rotation segments. The question is, how many segments can we use? Let me just copy that cylinder and paste it to a new scene file. And I'm just going to add a subdivision surface object here to subdivide the cylinder. And now let's find out how many rotation segments we can use. Now the minimum number you could use is 4. And as a general rule, you should pick even numbers for the rotation segments. So with 4 segments, we're getting something like this. And let me just increase the detail of the subdivision surface here. Now 4 rotation segments kind of work, but you can see we're not really getting a perfect circle here. So using 4 rotation segments, I wouldn't really recommend it unless it's a very small detail. So if it's far away from the camera, it's going to look like a circle, but up close it's just not looking that good. So 4 segments is not what we want to use for this example here. We could use 5 rotation segments, and this will give us a circle, but the problem with uneven numbers is the geometry we will have to create for this object, it's not tileable on all 4 sides, and that is something that's very important for what we're going to do. So 5 is not really an option. Let's change that to 6 rotation segments now. You can see with 6 rotation segments we're getting a nice and even circle here. So that is something we can use. And we're going to do one example with only 6 rotation segments. Usually a good number to start with is 8 rotation segments. It's not high poly, and it will give you a nice and round object. So 8 always is a good starting point. So if you want to go lower, 6 is the minimum number you should use, and of course you could use more, but make sure it's even numbers: 10, 12, 14, multiples of 2. So I'm going to close that. So let's change the rotation segments of our cylinder to 8. And now I'm going to add a bool object, and I want to make the plane the first child and the cylinder the second child of the bool object. And for the bool object itself, I'm going to keep the Boolean type at a subtract b, because we want to punch that hole in there. We're going to keep high quality, which is checked by default, and we want to create a single object. And I don't want to hide the new edges, because it will make it easier for you to see how the geometry cleans up as we start adding more geometry to the plane. I'm going to do a total of 4 examples for this hole, and we can use the bool object that we just created as a basis for each of these 4 examples. So what I'm going to do is I'm going to rename this to example base, and I'm going to make a copy of this one, and let's call this example 1, and I'll make this one invisible for now. So right now the bool object creates geometry that we can't really use. We have triangles and very stretched geometry here. So if I switch off the bool object and have a look at the cylinder, you can see that we have this vertical line here and this horizontal line, and that is something we could add to our plane object to clean up the geometry a bit. So let's go ahead and do that. And I'm going to make this plane object editable now, and let's switch the bool object back on, and in edge mode I'm going to select these two edges here. Then we can right click and select connect points edges, and this will create this additional edge here at the center. And you can see just by adding this edge we have cleaned up the geometry quite a bit. So we have four-sided polygons up here and down here, and the segments are even. And that's important because we're going to wrap this around a circle spline later, and we're going to use subdivision surfaces. So we need to make sure that the segments along the height stay even, because otherwise subdividing the object will not give us the result that we want. And maybe I'll just show you an example. So let me just create a new file here, and I'm going to add a cylinder, and let's give this 8 rotation segments. I'm going to add 1 cap segment. Then I'll make it editable and optimize it, and in point mode I'm going to delete the points here at the top and at the bottom, and I'm going to add a couple of control edges to hold the shape when we subdivide this object, something like this. So if I put this in a subdivision surface object, everything looks fine. So we get a nice circular shape and the object looks smooth. Now let's say you want to add additional details, or one additional detail to the cylinder, and for adding this detail you need an additional edge here. Now you can't really do that, because if you switch the subdivision surface object back on, you will see the object is no longer really circular. And that's the problem with round objects like these ones. We need to keep the segments even to make sure the shape stays the same. Okay, and that's why I want to make sure that these segments along the height are even. We can add as many additional edges horizontally as we want. It will not change the circular shape of the object when we wrap it around a circle spline, but it's very different with the height segments. Okay, so we need more geometry on our plane to clean up that geometry, and we've already added this vertical edge here. Now let's go ahead and add one horizontally. So I'm just going to connect these edges here, and just adding these two edges cleans up the entire geometry. So we have four-sided polygons all around, and that's exactly what we want, especially since we're using subdivision surfaces, and we're going to put this on or wrap this around a curved object. It's very important that we keep four-sided polygons, because triangles and n-gons, they will not work very well with subdivision surfaces. So that is our first example, and now we can go ahead and make this editable. And we have to do some more work on this piece of geometry, because we're going to copy this 16 times along the x-axis, and the number of times, let's say 10 along the y-axis, we're getting a lot of holes. So it's going to be 160 of these holes around that final object we're going to do. And you don't want to go in and create control edges and depth to this object for each of 160 holes separately. So we have to finish this object, and then we can copy it around and wrap it around a circle spline. Okay, so in polygon mode I'm going to select close polygon hole here, and I'm going to select this n-gon, and I'm going to right click and extrude inner, and let's do an offset of maybe 2.5 centimeters. And then we're going to extrude this n-gon down a bit, and let's do minus 2.5 centimeters, and let's do that again to add some depth, and we can now delete this n-gon. So we've created some depth and we've added the control edges that we need, and if we put this in a subdivision surface object, it should look okay. And it does. So it subdivides nicely. We're getting our circular shape punched into that geometry here. So that's looking good. So that was example 1. Now let's go ahead and do another version of this. And this one will be example number 2. And we're going to start the same way we did before. So we're going to add the vertical and horizontal edges. So I'm just going to grab these edges here and connect them, and I'll connect these edges here. So we're getting the same geometry as before, but this time I want to do things a little differently. So what I want to do is, I don't want to create these edges that go to the corners here. I want straight geometry. So I'm going to create edges from this point of the cylinder straight up to this edge here. The problem is that we need to keep our even height segments here, so I'm not going to cut from the points of the cylinder up to the edge here on the plane. What I'm going to do instead is I'm going to select these edges on my plane, and I'm going to use connect one more time, and this will split up our plane into 4 even segments. Now of course our cylinder is a little too big, but we want to keep those even height segments, so what we have to do here is we have to scale that cylinder down a bit. So let's hit T for scale and just drag until the edges are very close together. We're probably not going to get it perfect, so this is close enough. And to make sure that the points of the plane and the cylinder in these areas here are welded together, I'm now going to change a setting in the bool object. All the way at the bottom here you can see an option, it's called optimize points, and that is a tolerance value that will weld points together depending on how close these points are. So I'm going to change that to something like 2 centimeters, and that should fix the issue we're having here. So if I go back, you can see they're not fitting together perfectly, and if I change that to 2 again, these points will be welded. So now we have 4-sided polygons up here and down here, and we need to change these areas here. And in order to do that, we will need more geometry on our plane. So what we're going to do is we're going to use the knife tool, and I'll switch this to plane mode, and let's make sure to switch off restrictor selection here, and the plane needs to be XZ. I'm going to use snapping here, and now we can snap to this point on the cylinder and make a cut here, and we'll make another cut down here. So as you can see, that cleans up the entire mesh, and the geometry is flowing a little differently than on our previous example here. And we have 4-sided polygons all the way around, so that should subdivide nicely. So let's go ahead and make this object editable, and we're going to do the same procedure as before. So in polygon mode, I'm going to close that polygon hole here, and I'm going to select the n-gon and extrude inner, and I'm going to use the same numbers as before just to speed things up a bit. So 2.5 centimeters, and we're going to extrude it down twice and delete the n-gon. And let's test this in a subdivision surface object. You can see this one as well subdivides very nicely. Okay, so that is example number 2. For the third example, what we're going to change is the rotation of our cylinder. So let's grab this and let's hit R to get the rotation tool. And what I'm going to do is I'm going to rotate this cylinder like this to get this edge parallel to this one. And of course here I'm just eyeballing it, so I want to do this a little more accurately. So what we're going to do is select the cylinder, go to the coordinates tab down here, and there's a formula we can use to rotate the cylinder exactly to a position where this edge is perfectly parallel with this edge here. Now if you take this cylinder, it's basically a circle, and a circle has 360 degrees. So we have to enter 360 here and divide that by the number of segments, which is 8, and we have to divide that by 2. And if we hit enter, this will rotate our cylinder exactly to the position where these two edges here are parallel. So as you can see, the geometry the bool object shows us here is definitely not what we want. We have these triangles in the corners, and we have some very stretched four-sided polygons on the sides and at the top and at the bottom here. So again, we have to add additional geometry to our plane to fix that. And here what I want to do is, again, I'm going to create two edges from this point on the cylinder straight up to here. And again, we have to bear in mind that we want to keep our even segments along the height. So I'm not going to cut from the points of the cylinder straight up to here. What I'm going to do instead is, in edge mode, I'm going to select these edges here, and in this case I'm going to use the edge cut tool. Left click once, hold down your left mouse button and drag your mouse to the right to get these two new edges here. So the height segments, they stay even. And as with the previous example, our cylinder does not exactly fit the geometry of the plane, so we need to select it and scale it up a bit until the edges are matching up. Okay, maybe something like this. You don't have to get it 100% perfect. And now again, what I'm going to do is I'm going to change the optimized points value for the bool object. So let's bring this up to 2 centimeters to make sure the points up here and down here are welded together. And now we need to add the same geometry in the horizontal direction here. So let's grab our plane. I'm going to select these edges here and again use edge cut and add these two new edges. So that's not looking too bad, but we still have this triangle here which is created by the bool object. If I switch off hide new edges, we're getting these n-gons in the corners here. So we need additional geometry to turn all of these polygons into four-sided polygons. And of course I don't want to create vertical edges because this would change the height segments, and that is not what we want. So we're going to have to add horizontal edges, and we're going to add these up here and down here. So let's select the plane, and I'm grabbing my knife tool again. We're using the same settings as before, so we're in plane mode and the plane is set to XZ. Let me switch on snapping, and I'm going to snap to this edge up here and make a cut, and I'm going to make a cut down here. So now we've turned this plane object into four-sided polygons, and these should subdivide well when we use a subdivision surface object on this plane. Okay, let's make this editable, and as before I'm just going to switch off snapping here. As before, we're going to close that polygon hole and extrude inner and extrude this down twice and delete the n-gon. And let's do a quick test and see how that looks. And this example as well, it subdivides very nicely. So an object with geometry like this, we could certainly use that to wrap it around our circle spline. Okay, so that was example 3. Now let's do the last one. And for this one, I'm going to change the rotation segments for the cylinder. So instead of 8, let's try 6. And the geometry doesn't look too good by default, so we have to add additional edges to our plane. And we're going to do this the same way as in the previous example. So in edge mode, I'm going to select these 2 edges and use edge cut to create 2 new edges, because we need to match the geometry up with these 2 points on our cylinder. And the cylinder is a little too big, so let's scale it down to about here. Okay, trying to get it as close as possible. And again, I'm going to change optimize points to maybe 2 centimeters to make sure the points up here are welded together. So if I switch on hide new edges, you can see we have these 2 big n-gons here, so we need an additional edge running right through here, and we're also going to need additional edges here and down here. And of course we're going to do these in the horizontal direction because we need to make sure that we keep those height segments even. So let's go ahead and do that. Select the plane, and I'm going to select these edges here and connect them. And then I'm going to use my knife tool, switch snapping back on, and I'm going to make a cut here and another one down here. So again, we have 4-sided polygons all around this object, and that is something we can use to subdivide it and wrap it around the circle spline. So I'm going to make this editable and close the polygon hole, and extrude inner, and I'm going to extrude this n-gon down twice and then delete it. Let's put this in a subdivision surface object, and again we're getting something that looks quite nice. So now we have created 4 different versions of the same object, and each of these versions has a clean mesh with only 4-sided polygons, and the geometry is flowing a little differently on each of these examples. So now let's test each of these versions and see how they look when we wrap them around a curved surface and subdivide them. Before we do that, however, we need to resize our examples, and for now I'm just going to rescale them to our original segment here, which means that we're not going to get a perfect fit when we wrap these examples around a circle spline, but for this test it's going to be sufficient, and the distortion we'll be getting will be minimal, so we won't have to worry about that. And for our final version, we're going to do an object where everything fits together perfectly. Okay, so this plane, let me just go to model mode here, has this width and height. I'm going to copy that number here, and I'm just going to resize all of the 4 examples to that same size. And what I also want to do is I want to select all of the 4 examples, and I'm going to hit Alt G to put them in a null object. And this null object I'm going to make invisible, and I'm going to rename this examples 1 to 4. And I'm just going to copy and paste them into the scene. Now let's start with example number 1. Now we know we need 16 of these holes along the x-axis, and we're going to do maybe 10 holes in the y-axis. So for this I'm going to use a cloner, and let me just switch off example 4 and switch on example 1 here. Now by default the cloner is set to a linear mode. We're going to change that to grid array, and we don't need any copies in the z-axis, so I'm going to bring this down to 0. We need 16 copies in the x-axis, and let's do 10 on the y-axis. And we need to spread these apart, so we're going to use the same number we copied before, that is the width of the original plane, and we're going to have to multiply this number by the count minus 1. So we're going to multiply this by 15 and not by 16. And we're going to do the same thing for the y-axis. So copy this number and multiply it by 9. And it looks like example 1 is still too big. You can see down here it's still 100 by 100 centimeters, so I'm just going to change that to the size we need, hit apply, and now we should get something like this. Next I'm going to make this editable, but I'm not just going to hit C and make the cloner editable here, because this will create 160 objects that we would have to select and connect. There is a faster way to do that. We're going to add a connect object to this cloner, and we can make the connect object editable, and this will weld all of the copies together and weld the points. So it's a little faster and easier than making the cloner editable. And because we're going to use this cloner, or the same setup for the cloner for the other examples as well, I'm going to make a copy of this object. So let's drag out a copy, and let's delete example 1 from this copy, and this one we're going to call example 1. Okay, and let's make this editable. And we're getting a ton of selection tags here. I'm just going to grab these and delete them. And for testing these examples, I'm not going to use the N side because it only has 16 rotation segments. For testing these, I'm going to add a circle spline again. And I'm going to set this to XZ to put it on the floor and just change the radius to 100. And now we're going to add a Spline Wrap deformer to our example 1 and tell the Spline Wrap to wrap around this circle spline here. And if you zoom in, you can see that the extrusions are facing the wrong way, but we can easily change that by switching the axis of the Spline Wrap deformer to -X. Okay, and in order to weld the seams together, I'm going to use another connect object here. I'm also going to call this example 1, and I'm going to make this editable. And now we can put this in a subdivision surface object. So that is example number 1. Now let's go ahead and create the other examples. So I'm going to make a copy of this connect object, and I'm going to put example 2 into the cloner here. And let's make this visible. Oh, and it seems rescaling hasn't worked for this one either, so I'm just going to do this again. We have to copy the width or the height of the original segment we did at the beginning of the tutorial, and I'm just going to resize this. Okay, so this is example 2, and let's make this editable. And again, I'm just going to get rid of all of these selection tags here and use a spline wrap deformer and wrap it around the same circle spline and change the axis of the spline wrap to -x. Let's put this in a connect object, rename it to example 2 and make it editable, and use a subdivision surface object, which I'm also going to call example 2. And again, make a copy of this connect object and drag example 3 into there and make it a child of the cloner. And let's rename all of these objects, make it editable, get rid of the tags. Use Spline Wrap to wrap it around the circle spline, change the axis to -x, and use another connect object, make this one editable, and add a subdivision surface object, which we're going to rename to example 3. And now let's drag example 4 into this cloner here, make it visible, rename the cloner and the connect object, make the connect object editable, and let's delete those tags here. And once more, I'm going to use a spline wrap deformer here to wrap the object around that circle spline, and I'm going to change the axis to -x. Put this in a connect object, make this editable, and use another subdivision surface object to subdivide this example. So let's have a look at how each of these versions look. Sometimes it helps to show flaws in your mesh by using a material, and we're going to create one quickly. And what we're going to do is, in the reflectance channel under default specular, I'm going to change the width to something like 20, and we're going to increase the specular strength to something like 50% or so. And let's grab all of these examples here, right click on the material and select apply. So let's have a look at example 1. If I do a quick render here, it seems to look okay. What we're going to do now is we're going to find a camera angle that brings out the worst in this object. So let's maybe do something like this. And you can see here on example 1 we're getting a lot of deformation. So it looks nice and clean from certain angles, but if you render from an angle like this, it will look pretty nasty actually. I'm going to create a camera here, and let me put a protection tag on this one so I can use this camera to render the other examples from the same angle. Now we're getting all of this deformation here, and the reason is, although this object is by definition a clean object, we only have 4-sided polygons, it is not a good example for creating a cylindrical or round shape, or to put this on a curved surface. And the reason is we have all of these edges here meeting in this one point, and this is like a pole, and that is why we're getting all of this deformation here. Now let's have a look at example number 2. And you can see here this looks a lot cleaner, it's almost perfect. if you look really closely, you can see that we're getting a bit of deformation, but this is pretty much perfect. And it's not a big surprise, because if you take a look at the geometry we have here, it's very evenly spread out, and the polygons almost have the same size all over this object. So it's not really surprising that this really looks nice when we subdivide it. So this is definitely something we can use, especially when we wrap this around a curved surface. Now let's have a look at the third example. And this one, again, you can see a lot of deformation going on, and like the other ones, you know, from certain camera angles you can really get away with this, but the geometry on this one, it's not as evenly spread out as in the previous example. Okay, and depending on the camera angle, it will not look that nice, but it's kind of acceptable. It will look okay from most camera angles, I guess. Now let's have a look at the fourth example. And this is the one where we only used 6 rotation segments here. And this one, you can see it has more deformation than example number 2. So it's not looking as good as expected, although the geometry of this one almost is the same as that of example number 2. So we also have the geometry spread out nice and evenly across the object. But again, from most angles this will probably look okay. My preferred version, of course, is example 2, and although it's a bit high poly, it does give us a very clean result. So that is the one we're going to use to create our final version of the cylinder. So for this final version I'm going to copy example 2 and the original end side spline to a new scene file. And let's make these visible. Our end side spline, right now, it has the radius we want, but it only has 16 sides, and that is not enough because we had to add all that additional geometry in our basic segment to be able to fit that hole in there. So actually we're not going to need 16 sides for the end side. We're going to need 4 times that amount to make sure that our object can be wrapped around that end side spline. So let's change the number of sides to 16 times 4. Now this also means that the length of this spline has changed. So I'm going to make this editable, and I'm going to edit project info, and under the structure tab I just have to reselect my spline again and again go to project info. We can now see the new spline length here. So we're going to copy that, and we're going to add a plane and put it to -z, and we don't need any height segments, but we want 64 width segments, and let's change the height to 150 here, and we need to copy the spline length into the width field here. If I use a Spline Wrap deformer to wrap this plane around the end side, it will now be a perfect fit. And that is no matter if I set the mode of the Spline Wrap object to fit spline or keep length. Okay, you can see nothing is changing here. So we're getting that perfect fit. And now we can make this plane object editable, and I'm going to delete everything except for 4 segments, because that is how many segments our plane object with a hole has. So we have 1, 2, 3, 4 segments. We're going to keep these, and we're going to invert the selection and delete all of these points here. So now if we select all of these points, we can see how wide this segment is, and that is the size we need for our example 2 here. So let's go ahead and select it, and I'm switching to model mode here, and I'll change the size. Whoops, something went wrong here, so let me just try that again. I'm going to copy the width of these 4 segments, and I'm going to change the size of example 2 to these numbers. So now we can get rid of this plane here. Okay, and now that we've done that, we can start copying this object around. So we need 16 of these copies in the x-axis, and let's do 10 on the y-axis. So I'm going to add a cloner object and make our example 2 a child of this. And like for the tests we did earlier, I'm going to switch this to grid array with no copies in the z-axis, and we're going to do 16 in the x-axis and 10 in the y-axis. And we have to enter the size of our example 2 here and multiply this by 15, and over here we need to multiply that number by 9. So now let's add a connect object and make this editable. And I'm getting rid of all of the tags here. We don't really need these. You can use another Spline Wrap deformer and tell it to wrap this object around the inside spline. And as before, we'll have to change the axis to -x. Well, actually, let's do this a little differently. I'll just go back to this point here, and we're going to keep the cloner linear. We don't want any movement in the y-axis, so I'm going to set this to 0, and instead I'm going to copy these along the x-axis, and we're going to use the width of our example 2 here, and we're going to do 16 copies. And I'm going to make a copy of this cloner and move it up on the y-axis by the same width and height of the and move it up 39.254 centimeters in the y-axis. And for this example, we're going to do 17 copies. Because I want to offset these holes a bit, and we need to move this cloner over on the x-axis by the width of our segment divided by 2, and actually we have to move it in the negative direction here. Okay, so now we can put both of these objects in a connect object. Well, I guess we could use one connect object for both of these, so let's just drag them in here. And I'm going to make this connect object editable. Let's go ahead and delete those tags. And now what we can do is, in point mode, I'm going to delete these points over here and these ones over here. And in model mode, I'm going to go to Mesh, Axis Center, and bring up Axis Center, and we can use the default settings here. Well, maybe let's bring the y-axis down all the way to 0 and hit execute. And now we can put this object at the center of the Cinema 4D grid. You can either zero out these numbers here, or you can go to character, commands, and reset PSR, and this will put it right at the center of the Cinema 4D grid. And now we're going to use this object, and you can see the height here. I'm going to copy that number, and we can use another cloner to add additional copies in the y-axis. So let's go ahead and add that cloner, and we're going to do 10 holes, which means we need 5 copies, and we're going to move each of these by 78.5 centimeters. Okay, so let's put this cloner in a connect object, make the connect object editable, and now we can add a spline wrap deformer and wrap this object around our inside spline, and let's change the axis of the spline wrap object to -x. Okay, let's put this in another connect object, make this editable, and add a subdivision surface object. And let's just copy the material we created here and paste it to this new scene file and drag it onto our object here. Okay, and this is the final version of our object. So we're getting very nice deformation, a very clean mesh, and an object that is pretty much perfect. Okay, and this is the end of this tutorial. Thanks for watching, everyone, and I'll see you again soon.